Bismillahirrahmanirrahim. Assalamu alaikum. How are you guys? This is Mansoor Ahmad with Word Chemistry. I hope that all are going well. So, guys, we will discuss another topic about the electrophilic aromatic substitution reaction of the benzene. Today's topic will be a little strange because we are going special name to the reaction. So what is our topic about today? That is basically related to Friedel-Craft Arylation. So what is Friedel-Craft Arylation? We study about the Friedel-Craft Acylation and Friedel-Craft Acylation. Today we will read about the Arylation. So what is the Friedel-Craft Arylation? This is nothing. This is just the example of Friedel-Craft Acylation. Understand? You cannot find the reaction of Friedel-Craft Arylation by this name in any book, in any source. Why? Because this is the example of Friedel-Craft Acylation. So basically Friedel-Craft Arylation is the example of Friedel-Craft Acylation. Just in previous example, that was Friedel-Craft Acylation. We replace the hydrogen atom of the benzene by the help of acyl group. In that case, the acyl group, the R was aliphatic. While today we will add the same acyl group into the benzene ring, but here the R group is not aliphatic, that is aryl group. So that's why we will call this reaction by the name of Friedel-Craft Arylation. Even it is the example of Friedel-Craft Acylation. So since we replace the R by aryl group, that's why this is known as arylation. So what is the meaning of Friedel-Craft Arylation? Here the word arylation means addition of aryl group. Addition of aryl group. So we will discuss that what is aryl group. This is very simple, dear student. In Friedel-Craft Acylation, what we did, we simply replaced the hydrogen atom of the benzene by the help of acyl group. This was our electrophile in Friedel-Craft Acylation. But today we, dear student, we will replace this R group of the acyl group by the help of an aryl group. So we will discuss that what is an aryl group. Dear student, this is a benzene molecule. Understand, here 6 hydrogen atoms are attached. We know C6H6 is the molecular formula of benzene. C6H6, this is the molecular formula of the benzene. This is called benzene, or sometimes this is also known as pene. Again, pene is the name of benzene. Understand what happened? What does mean by an aryl group? I am trying to understand an aryl group. Suppose this is a benzene molecules, which general formula, molecular formula is C6H6. If we replace one of the hydrogen atom of the benzene molecule, so what will it becomes? It becomes simply now C6H5. Why? Because we replaced one hydrogen atom. So now this is known as phenyl group. This is what, dear student? This is known as phenyl group. Understand? Phenyl is simply the replacement of hydrogen atom of the benzene. When we replace one hydrogen atom from the benzene, then it becomes phenyl group. Understand? This is called phenyl group, or this is also known as aryl. This is also known as aryl, which is represented by AR. Do not mix this symbol with the argon, because argon is also represented by AR. Understand, dear student? So this is aryl, basically aryl. So now what did mean by an aryl group? Simply, when we replace one of the hydrogen atom of the aromatic compounds, then it is called aryl group. Since benzene is itself an aromatic compound and we replace its hydrogen, that's why it is known as aryl group. So basically in Friedel Craft Arylation, we replace this R by the help of an aryl group. I mean we will introduce an aryl group now. So this is our electrophile in case of the Friedel Craft Arylation. I hope that you have understood well about this. So you did understand this. I think you have gotten the point. Now you have to keep one point in your mind. As I told that what is aryl? Aryl is the simple replacement of the hydrogen atom from an aromatic compound. Suppose again I am taking this is what? This is again one benzene molecules. Here are 6 hydrogen atom attached with this benzene molecule. Now what I am taking? Simply I am replacing one of the hydrogen atom from it, which becomes aryl. Now this time I am adding C double bond O. Just I attached one of the carbonyl group, C double bond O. This is what? This is a carbonyl group. Just I added one carbonyl group with the phenyl group. Now it becomes benzoyl. What? Now this is called benzoyl, which is represented by BZ. This is its symbol. Understand? This is called benzoyl. So today basically we are reacting benzoyl. Now still there is one valency of carbon remaining. We will add air X halogen. So it becomes benzoyl halide. This is our arylating agent today we use in this reaction. Understand, everyone? If here comes a chlorine atom again, then it is called benzoyl chloride. If there comes a bromine atom, it is known as benzoyl bromide. If here comes iodine, it is known as benzoyl iodide. It depends upon the halogen which you use in this reaction. Understand? One is there is one more term you have not to mix that with this. This is called benzoyl. Understand? This simple benzoyl is what? When you added just a carbonyl group with phenyl group, or I mean when you attach just one carbonyl group with a phenyl group, then it is known as benzoyl. When you attach an halogen that is X, then it is known as benzoyl halide. Understand? I mean there is O is present in case of benzoyl. There is one more group you have to remember, that is called benzyl. What do you want? Benzyl. Benzyl. There is no O. O is absent in this word. Now what does mean by benzyl? Benzyl is very simple. You know, this is what? This is again a benzene molecule. Here is 6 hydrogen atom attached with this, not 6, 5. Instead of one hydrogen atom, here I am writing CH3. Now this is what? This is known as methyl benzene. Methyl benzene. The more common name of this compound is toluene. Toluene. This is what? Toluene is the common name of this compound. Now what does mean by benzyl? If I replace one of the hydrogen atom from toluene, understand? If I simply replace one of the hydrogen atom from toluene, then it is known as benzyl. Understand? This is what? This is benzoyl, which is quite different from benzyl. And this is benzyl. In benzyl, you have to keep one point in your mind. You have to remove the hydrogen atom just from this part. Understand? You cannot remove hydrogen atom from this case in case of benzyl. Understand? You have to keep this point in your mind. Now this is CH3. If I remove one hydrogen, then it becomes CH2. Now this is known as benzyl. What is its formula? Very simple. C6H5CH2. This is the formula of benzyl. Understand? Now a question rises. If instead of this CH3, if I replace one of the hydrogen atom from these either carbons, from these 5 carbons, now what will happen? If I replace the hydrogen atom from this carbon atom, I mean from this carbon or this in this pipe, instead of this CH3, now what will happen? There will be another group which is known as toluene. What? There will be another group which is known as toluene. I will tell. Suppose this is again hydrogen. Here is a CH3. There are 5 more hydrogen atom attached with this benzene. Understand it, don't? Now what happened? If I replace this hydrogen atom or this instead of these CH3 hydrogens, then it is called toluene. Suppose I am removing this hydrogen atom. Now this group is known as toluene. This is what? Simple toluene. What is its formula? The formula becomes C6H4. Now this time you have to write 4 hydrogen atom, because count 1, 2, 3, 4 and CH3. This is what? This is the formula of toluene. Understand that? I hope you have understand this point well and keep this in your mind. Now this is our reaction of today in Friedel-Craft Arylation. The Friedel-Craft Arylation reaction is very simple. Suppose this is the hydrogen atom. Now as I told, today we react benzoyl halide. Suppose this is X atom. Understand? This is what? This is benzoyl halide. So this hydrogen atom of the benzene will replace with this hydrogen will react with this X atom, forming HX. That is halogen acid. Plus this is our electrophile, which will attach with this benzene. Understand? It will form a product which is this is what? This is our final product formed in case of Friedel-Craft Arylation. This is known as benzaphenone. Understand it, student? This is what? This is simple benzaphenone. Benzaphenone is our final product in case of Friedel-Craft Arylation. Now if I write the same catalyst will be used as we used in Friedel-Craft Acylation and Friedel-Craft Acylation. So now if I write the general definition of this reaction, so how it will be? It is very easy. The replacement of the hydrogen atom of benzene by the help of an aryl group in the presence of living acid using as a catalyst to form benzaphenone is known as Friedel-Craft Arylation. Dear students, again I am telling that Friedel-Craft Arylation is the example of Friedel-Craft Acylation. This is not a different thing. This is the same example of Friedel-Craft Acylation. The only difference is that in Friedel-Craft here R is what? Aliphatic chain. If I use an aromatic compound that is like this, now to this reaction I am giving a particular name which is known as Friedel-Craft Arylation. What is the meaning of arylation? The meaning of arylation is just the simple of addition aryl group into the benzene molecule, as we are adding an aryl group. So I am writing here the general definition of this reaction, which is very simple. So what is the general definition? The replacement of hydrogen atom of benzene ring by the help of an aryl group in the presence of in the presence of Lewis acid using as a catalyst to form benzaphenone. Benzaphenone is our final product formed in this reaction. To form benzaphenone is known as Friedel Craft Arylation, is known as F-C Arylation, shortcut. This is the definition of Friedel Craft Arylation. So write it after the definition. Now we will write its mechanism, which is quite important. In mechanism, I will explain that why we are using Lewis acid, and the Lewis acid should be anhydrous Lewis acid. You have to write this with Lewis acid. The Lewis acid should be anhydrous. Anhydrous means without water. I will tell the reason. Understand, student? Take the screenshot of this. I am going to write its mechanism. So we will discuss its mechanism. The mechanism of electrophilic aromatic substitution reaction is highly easy and just consists of only 3 steps, in which the first step is always generation of an electrophile. Why we generate an electrophile in first step? Because this is electrophilic aromatic substitution reaction of benzene. In case of electrophilic aromatic substitution reaction, the initial attack is always done by an electrophile. That's why we generate an electrophile in first step of such kind of the mechanism. Understand? Again, if I write the general reaction, I will first write general reaction. After that, we will explain its mechanism. This is what, this is not general, this is a particular example. Suppose here I am taking chlorine. Now this is known as benzoyl chloride. Benzoyl chloride. And this is simple benzene molecule. And here we are taking anhydrous Lewis acid. Anhydrous, without water. Anhydrous means without water. Suppose that is AlCl3, aluminum trichloride. Which kind of the Lewis acids? What are Lewis acid? And their general representation FX3. This is what Lewis acid. X atom may be chlorine like this FeCl3. It may be bromine FBr3. Similarly, aluminum trihalide. If X is chlorine, then it is AlCl3. If X is bromine, then AlBr3. And some more Lewis acids are there which we can use in this type of the reaction. But these are the general Lewis acid used in this reaction. Now what happens if I react benzoyl chloride with benzene in the presence of Lewis acid? Simply this hydrogen will react with this chlorine atom, forming halogen acid, that is hydrochloric acid. Plus this is our electrophile. This part is our electrophile which will take the place of this hydrogen atom. I mean substitution reaction will be there. So it will form benzaphenone as a final product. What is benzaphenone? Very simple. When you just put a carbonyl group between two benzene molecules, then it forms benzaphenone. This is what? This is benzaphenone, which is our final product. Now we are coming to the mechanism of this reaction. Mechanism of this reaction. It consists of just 3 steps. Step number 1. To step number 1, we always give a particular name that is known as generation of electrophile. As I told, the reason that first step is always the generation of electrophile, because these are electrophilic aromatic substitution reactions. Understand how we form electrophiles? Just take the reactant acylating agent, that is C double bond O and chlorine. With this we are using aluminum trichloride. Why we use Lewis acid, that is aluminum trichloride, in this reaction? Since Lewis acid basically what accepts the lone pair of electrons, accommodates the lone pair of electrons. That's why we use here Lewis acid. There are always vacant orbitals with the Lewis acid. Due to this reason, they accommodate the lone pair of electrons. And now what is the advantage to accommodate the lone pair of electron? Now I will tell this reason. We know that there are 3 lone pairs of the electrons with chlorine atom. Now just this Lewis acid will attract this lone pair of electron from chlorine atom. Understand? As aluminum attracts the lone pair of electron from chlorine atom, there will be a positive charge on chlorine atom. Since to make a positive charge on the chlorine atom, it is highly unstable condition. Now what will happen? As positive charge comes on chlorine atom, the chlorine becomes unstable. That's why chlorine immediately attracts the electron from carbon atom to stabilize itself. It will form these two. Now this is what? C double bond O positive. There will be a positive charge on carbon atom. Why? Because the chlorine attracts the electron from this carbon atom. Now as there is a positive charge on carbon atom, this is our electrophile. This whole is what? Benzoyl. Since there is positive charge on benzoyl group, that's why it is known as benzoyl cation. Benzoyl cation, which is our electrophile. Now this will attack on the pi bond of benzene. Understand? Plus here will be AlCl4 minus 1. Why there is a minus charge? Because this chlorine attracts the electron from this carbon atom. Understand? Since Lewis acid help us in the generation of electrophiles, if there was no Lewis acid, how this electrophile would be possible to form? It is impossible to form electrophile. That's why we are taking Lewis acid. Understand? Now how this vacant orbital is available with aluminium? That's Lewis acid. I am telling its reason. Suppose this is the atomic number of aluminium, that is 13. What's its electronic configuration? 1s2, 2s2, 2p6, 3s2 and 3p1. If I write it in blocks, then what happened? 1s2, there are 2 electrons in first shell. Understand? 2s2, again there are 2 electrons in 2s. Now this is 2p. Since there are 3 more subatomic orbitals in p, therefore I am showing them. That's 2px, 2py, 2pz. All of them are filled because there are total 6 electrons. Each subatomic orbitals will accommodate 2 electrons. Now this is 3s. Again there are 2 electrons. Now this comes again, p comes. There are again 3 subatomic orbitals. That's 3px, 3py and 3pz. Now there is only 1 electron in 3px. What happened? Just these 3s and 3px, 3py, 3pz are degenerative atomic orbitals. Degenerative atomic orbital means that they are of same energy. So simply these 3x, 1 electron of the 3x will jump to 3py. Now this is the electronic configuration of aluminium in excited state. There are 3 half filled orbital with the aluminium, that is 3s, 3px, 3py. So due to this reason, aluminium basically make 3 bonds with chlorine atom. Understand? This is what? This is 1 chlorine atom which make bond with the aluminium. Suppose I am showing air. This is the another chlorine atom which forms bond with aluminium, and this is the third one. Understand? here I am showing. Now this is aluminum trichloride, but if we look here, still there is one vacant orbital with aluminum, that is 3pz. 3pz atomic orbital is still vacant with aluminum. That's why which I wrote here, I show here. Understand, everyone? This is what, this is the same vacant orbital which is present with aluminum, that is 3pz. I hope that you have understood well. So this is why we are using what Lewis acid as a catalyst in this type of the reaction. Reason number 2, that why we are using anhydrous Lewis acid, that is Lewis acid with water. If suppose I use hydrous Lewis acid, the Lewis acid with water molecules, then what would happen? Simply this is what, these are the lone pair of electron present with oxygen atom. If I use hydrous Lewis acid, that means water is present, then simply this aluminum will attract the lone pair of this oxygen atom. If this attract the electron of this oxygen atom, so how we can generate then this electrophile? Because aluminum will make its bond with this oxygen. Now this becomes what, useless for us. There is no need of aluminum trichloride using as a Lewis, because it already made bond with oxygen, so it cannot further help us to generate this electrophile. So that's why we are using anhydrous Lewis acid with water molecule. That is the reason. So now if there is no water molecule, now it cannot make bond with the oxygen atom. So now it is compelled to make bond with this chlorine atom. Understand? This is the first step, which is known as generation of electrophile. Now coming to second step, step number 2, which is known as formation of benzene ion. Formation of benzene ion. To this step there is a particular name which is known as sigma complex, sometimes also known as formation of rhenium ion. Now I will explain the reason of all. Do not worry. Understand, everyone? Now what happened? This is a benzene molecule. This is one hydrogen of its. As now electrophile forms, that is benzoyl cation, double bond positive. Now what happened? The double bond of this benzene molecule will attack on this C positive. It will form a complex. It will form simple a complex. This is hydrogen and this is C double bond O. This is second phenyl group. Attach this group. Understand? Here is double bond, there is double bond, and here comes a positive charge. Why there is positive charge? Because this carbon attracts the electron from this carbon and share this electron of this carbon with this C positive. That's why here becomes a positive charge. Now this is known as benzene ion. Since there comes a positive charge on benzene structure, that's why it is known as benzene ion. This is also known as a sigma complex. Be very interested. Why it is also known as sigma complex? Again, very simple. As there is a double bond, pi bond, which converts here. I mean here the pi bond is finished, that is simply converted into single bond, and single covalent bond is known as sigma bond. Since pi bond is converted into sigma bond, plus there is a positive charge, a complex structure is formed. That is why it is known as sigma complex. Sigma bond with a complex structure, because there is a positive charge. This is known as sigma complex. Now this is what? This is a complex. Understand? This is a stabilized compound because there is a resonance. But in this step, in case of sigma complex, we destroyed the conjugation, not 100%, we have not completely destroyed this structure, but still there is a resonance possible in this structure. Why? Because there is a condition for the resonance. Whenever there is a positive charge, there is a double bond that is directly attached with single and that directly enters is attached with positive charge. Now this is a conjugated system. In such type of system, the resonance is possible. Just the same condition is present in this molecule. Look at this, is double bond directly attached with single and the single is attached with positive. So this is also a resonance stabilized structure, but this structure is not more complex stable as compared to this one, because in this structure here one double bond is broken, is destroyed, and that's why it destroyed this resonance as well. Understand, everyone? Now what happens? Simply this positive will shift here, it will form a resonating structure, that is now positive double bond will be there, positive charge now come on this carbon, because the carbon of this electron is shifted towards this carbon. Understand? Hydrogen C double bond, again there is one phenyl group. Understand? Now still the condition is present, double bond, single bond, pi bond. Now this will again shift here, it will make one more resonating structure, that is hydrogen C double bond, and this is again phenyl group. Now look, there is double bond and here is double bond and there comes positive charge. Is there any conjugated system present more? There is no more conjugated system, because positive charge is present, single is present, but there is no directly double bond attached. Here is also single, there is also single, and even there is also a single bond. So there is no more a resonating structure possible for this complex. Now this again convert to this one, because double single direct positive. Now it will convert to this one back will convert to this one, and this will again convert to this one, and that convert to that one. The process is continued until one of the hydrogen atom is eliminated from this sigma complex. The only possible way for this sigma complex is to eliminate one hydrogen from itself. As it eliminates one of the hydrogen from itself, it recovers its conjugation back. So that's why this becomes our step 3, which is known as elimination of the proton, which gives us a stable and most stable product again towards us. So again we are coming to step number 3. You have to memorize, these are just the two structure of this sigma complex, resonating structure. Now this is a step number 3, which is known as elimination of proton. Elimination means removal of proton or elimination of proton. Understand, everyone? In this step, one proton will eliminate. Why? Because it will regenerate the conjugation present in this molecule. Understand? Now who will help us in the elimination of the proton? Is this part will eliminate, or this part will help us in the elimination of proton, because it possesses an additional chloride ion. Understand? The same chloride will attack on this hydrogen on this proton. How it will? Just check this step. There is hydrogen C double bond, and there is again a phenyl group. Understand, isn't? There is positive charge, double bond, double bond. Now with this we are reacting AlCl3 and Cl negative. Understand? Now this Cl negative charge of this chlorine will attack on this hydrogen. In turn, proton will give its electron to this carbon, and carbon will share its to this C positive. What will happen? Just the final product, that is benzophenone, will form. Again here double bond regenerates, C double bond O, and this is another phenyl group. plus here HCl. HCl is produced with AlCl3 aluminum trichloride. As aluminum trichloride is our acid, the job of an acid is just to initiate a reaction and regenerate itself in original state as it was used in the initial. So in the initial state, Lewis acid was in the form of AlCl3. Again here it forms in the same form, that is AlCl3. Understand? Plus HCl is formed hydrochloric acid, which was also formed here. Understand? In general reaction. Plus there will be our final product, which is known as benzaphenone. Understand? This is what? That is benzaphenone. So this is all about the Friedel-Craft Arylation, which is just the example of Friedel-Craft Acylation. In such type of the reaction, we are taking aromatic compound, that is aryl group. Since we add aryl group in such type of the reaction, that is why it is known as Friedel-Craft Arylation. I hope that you have enjoyed and you have learned about the Friedel-Craft Arylation and you have enjoyed the lecture. If you have enjoyed and learned something from my this lecture, please subscribe the channel and share this lecture with your friends. Inshallah, we will meet with one more class. See the next time. Bye bye. Tata.